So let's take a look at the difference of perfect squares. We use this method when there is no linear term for your quadratic, and it's a perfect square being subtracted from a perfect square. So for instance, we have 25x squared minus 9. So 25x squared is a perfect square because 5x times 5x will give you 25x squared. And then 9 is also a perfect square because 3 times 3 gives you 9. And notice you have the two perfect squares with a subtraction in between. So we're going to look at how to actually solve by factoring the difference of perfect squares. And to do this, we're going to get 5x minus 3 times 5x plus 3. And that's because we know 25x squared comes from 5x times 5x. And then we have the 3 times 3 gives you 9. We have to do minus in one and plus in the other because that's going to make you where the linear term is canceled out and gives you this minus 9 here. And then we call this a conjugate pair. So when I get to this point, before I move on to actually solving for x, I just want to mentally double check that I did this correctly because sometimes we make those careless mistakes, right? So I'm going to think 5x times 5x. Is that 25x squared? It is. Okay, so is negative 3 times positive 3 negative 9? It is. And then we think about that linear pair part. We get 5x times 3 is 15x. And then we have negative 3 times 5x is negative 15x. So we get 15x minus 15x gives us 0x, which is why we don't see that linear term in our quadratic. So the next step is to actually solve. But right here, we have factored the equation. And to solve, we take both of our factors and set equal to 0. So we set 5x minus 3 equal to 0 and 5x plus 3 equal to 0. And then we just solve for x. You add 3 to both sides and divide by 5. So when we add 3 to both sides, we get 5x equals 3. And when we divide by 5, we get x equals 3/5. Now we're going to do a similar method to solve 5x plus 3 equals 0. And we subtract 3 from both sides, divide by 5, and we get x equals negative 3/5. So you might notice that these are basically the opposite of each other, right? We have 3/5 and then negative 3/5. So we can actually write it like x equals plus or minus 3/5. So x equals plus or minus 3/5 would be your x-intercepts, and it's the solution to this quadratic. So we factored it here, and we solved for it and got x equals plus or minus 3/5. Now let's take a look at our other equation. We have 25 minus 9x squared equals 0, and then like right now we know that this is a special case because like I'm telling you, but what if you were just given this and you weren't sure? Well, if you see that you have two terms being subtracted and you don't have a linear term, you probably just want to take a second and think like, are these perfect squares, right? 25 is a perfect square, 9x squared is a perfect square. So we can use this method. Note that if you had something like 26 minus 9x squared, you couldn't use it because 26 is not a perfect square. And then if you had 25 minus 9x, you couldn't use it because 9x isn't a perfect square because x times x would give you this x squared. So we can't use that either. So again, we're going to set up our two groupings. We know we're going to have two groupings set equal to 0 in this case. And then we're going to have a plus in one, a minus in the other. And it really doesn't matter which one has a plus or the minus. So then we think, okay, we have 25. We get that from doing 5 times 5. And then we have 9x squared, which we get from doing 3x times 3x. At this point, if you're still unsure, just double check. 5 times 5 is 25. 5 times negative 3x is negative 15x. And we have 3x plus 5, which is 15x. We get negative 15x plus 15x, which makes us not have a linear term. And we have 3x times negative 3x because it's negative 9x squared. And so we know we factored correctly. If you're asked to solve and not just factor, then we take both of these factors and set equal to 0. So we're going to get 5 plus 3x equals 0 and 5 minus 3x equals 0. When we solve, we're going to get 3x equals negative 5. So x equals negative 5/3. And over here, we would get x equals positive 5/3. You can leave it like this, or if you want to write it more simply like we did in the last section, the last example, we get x equals plus or minus 5/3. And that is how you use the case of difference of perfect